This week I'm going to be talking about a new element I created over the last couple weeks called am-breakpoints, as well as going through how to write unit tests for an element in Polymer 2 using Chai, Mocha, Sign-On, and the web component tester through the Polymer CLI. To start things off, I want to talk briefly about my new element that I published to webcomponents.org. In future videos, I'll probably be breaking these kinds of announcements into their own separate videos so I can talk more about the elements independently. However, for this case, since I'm going to be using am breakpoints for the example code for the unit test, I felt it kind of necessary to talk about the element itself beforehand, so the tests make a little bit more sense as you're going through them. You can view this element by searching for am breakpoints on the webcomponents.org website. I'll also be posting links in the resources section at the end of this video, as well as in the description below the video. am breakpoints relies on the material design specification for responsive UI, and you can see in this nice graphic as it transitions from the screen size over time, the different devices that are affected at each resolution of that screen size. Google also provides a tabular representation of the graphic we looked at previously. am breakpoints relies on a combination of these two graphics in order to build out all of the dimensions and queries that we'll be using, as well as providing columns and gutters that we can rely on. am breakpoints also derives its breakpoint names from this table. So, for example, small handsets in portrait mode would have a breakpoint named small-handset. Similarly, a small handset in landscape mode would have one labeled small-handset-landscape. And then obviously the window ones keep as is. So extra small is X small, small is small, and so forth. This also gives us the different column layouts and gutter layouts as defined by the breakpoints. You can see the am breakpoints element in action using the demos provided with the element. This is going to transition across a few different resolutions using the Chrome dev tools to emulate different devices. It works the same on mobile devices as well. I was actually able to test it using the Polymer serve on my network against a couple of different mobile devices that I then connected to that server. You can check out the demos by downloading the element and running it yourself. You can also take a look at them on the webcomponents.org page. However, since webcomponents.org sandboxes all demos into iframes, you're going to notice kind of an issue there as the iframe gets its own resolution independent of the device it's running on. This last demo here is enabling a master version of the am breakpoints. What this does is it overrides the default controller for the am breakpoints, and this is set up so that am breakpoints only ever attaches one query for each breakpoint you generate. If you change and add a master element later, once that element is attached, it will replace the current one that's running, which previously was the first element attached into the page. This is going to change available breakpoints, as you can see through this demo, to just the ones that are enabled through your new queries that are assigned to the master element. If you don't assign any additional queries, it'll default back to the normal ones, which are all the material design breakpoints. Now that we've got some context about the element that we're going to be testing, we need to add our configurations in order to enable our unit tests. So here I've got the updates we're going to have to make to the Bower JSON file in order to install all of the dependencies we're going to need to run our tests. Now that we have our dependencies installed that will let us run our unit test, I go ahead and install my dependencies to run my linter as well. I base it all off of the Google configuration, which is what the Polymer team uses, and then I inject the chai expect syntax so that we can run our unit tests without our linter freaking out, and I've used the HTML plugin so that it can read the JavaScript within our HTML files. Last, I just include a small little script section to make life a little bit easier when running the linter, since as you can see, it's not exactly easy to run from a command line standpoint. This will also come in extremely useful later whenever we start talking about continuous integration on our elements. Now that our linter is installed, we need to set up an ESLint file in order to configure how it's going to run the linter. The first thing we need to do is include the recommended linting as well as the Google's config, and then we can set up our environment. I like to add a few extra rules that are a little bit more keen to my style of development, but in this case, the only thing that's actually important here is that we have our plugin set up as well as our global variables that we're going to be using in this element. Next, we're going to have to add a test folder to our element. This is going to contain an ESLint file that's going to be modified just for our testing elements. It's also going to contain a test file for each individual element that we have, as well as our index file for running our entire suite of tests all at once. As long as we don't set the root property on our ESLint files, it will continue to propagate up the chain, which means that if we have an ESLint file within our test folder and the previous ESLint file in the parent directory, it means that it'll inherit everything from the parent directory. So this allows us to create an ESLint.rc file within our test directory that only contains the deviations needed to lint our test files and nothing else. As you can see, we need to add Mocha as our environment. This is going to be our test runner. We also need to include the chai-expect plugin that we'd installed previously, since we're using the chai.js library for our syntax. Unfortunately, these two don't include all of the globals that we need, so for us to be able to use everything, we have to include a few on our own. Last, I like to disable the no unused expressions rule so that I can clean up my tests code just a little bit. Now that all of our configuration is done, we can start setting up our test framework. So what we need to do is add in an index.html within our test folder that will instantiate our web component tester, as well as load the suites of elements that we're going to be testing into the tester itself. You notice at the bottom where we load in our suites that each element actually gets 2 entries within this array. And this is because we want to test our elements against both the shadow DOM as well as the shady DOM. This is going to cause our test runner to run every one of our tests twice, so we end up with an inflated number of unit tests, which is unfortunate, but we want to make sure that it does get covered in all environments. Now that we've set up the references to our suite, we need to go ahead and start building out that file. The first thing we need to do is import the 2 scripts, the Web Components Lite and Web Components Tester, to set up our testing environment, and then we can link to the element that we want to test itself. Now that we've imported everything we need to run our tests, we need to start setting up our test fixtures. Polymer provides us with the test fixture element, which is a nice, easy way to import and instantiate instances of our element. So here I'm actually creating 3 separate fixtures that will be used at different points throughout our testing. Now that we've finished setting up our environment and adding our test fixtures, we can start writing tests that rely on those test fixtures. The first thing we need to do is create our wrapping describe. I like to just label mine as the element that I'm going to be testing itself, so I have a nice reference point to it later. A describe is just a grouping for us to put tests within. We can create what you see here as a before each that will run before every single test. It will also run before every describe that is labeled within this grouping. Next is the it statement, which is what we'll actually use to write our tests within. Those will be grouped within describes, and for behavior-driven development, follow the syntax as you see here, always starting with should. To keep my test suites clean, I like to go ahead and group each set of tests based on the functionality that it performs. I'll often group it based on literally the method that is called to invoke it. Now that we've got our basic tools covered, I'm going to go into depth on each of those. To start things off is going to be the before each. It allows us to create a small set of code that runs before each test within its scope. The scope is defined by the describe statements as mentioned above. In this case, this before each is going to run through and replace any reference to iron media query with what I refer to as fake media query. What this does is it prevents the iron media query from instantiating and running its logic so that we don't have to worry about testing across things that were already tested through the Polymer team. The next 2 lines will instantiate our basic and slave fixtures. And finally, we're going to flush that to ensure that the DOM is loaded before we use any of it. A flush is a helper function that's provided to us as part of the Polymer test suite that will clear out the DOM and ensure that any asynchronous operations have finished. Since it is an asynchronous operation, we need to call the done method that is provided to us in order to ensure the test knows that it's completed its operations. To start things off, we're going to create a couple of it statements that'll test our basic template structure. Since our logic requires us to only have instances of our media queries attached for our master element, and we need to support master elements being attached after the other elements have already been attached, we're going to go ahead and start things off by instantiating our master fixture and then flushing to let all the DOMs update. Once our DOM updates have been resolved, we're going to go ahead and look at the templates for each of these, do a query selector to see how many fake media queries were attached, and then check to make sure that the only one with media queries is the master element itself. And since we're using flush, this makes this test asynchronous, so we need to make sure to pass in the done variable and then call it as a function whenever we're done with all of our operations, so the test suite knows that it's finished its test and won't time out on us. Our second test here is very similar. It's just making sure that all of the queries that were provided to the master element were actually stamped into its DOM. Now that we've taken a look at some asynchronous tests, we're going to take a look at some synchronous tests. To start things off, let's take a look at the sign-on-spy reference in this code. What sign-on-spy is a helper function provided by the sign-on.js library to replace a function with a fake function that has no return data. The sign-on library also provides a helper function called stub that can return additional data as well as replace the function. In this case, we just want to make sure that calls were made to our function with the correct data, so we're using spy. Once we replace the function in the master, we can make a call to the function we want to test on the slave and provide it our instance of master. After that, we're going to take a look at the expect statement, which is what we expect to have been performed once our test was run. In this case, we're expecting that the master's remove event listener function has been called 3 times with the data that was provided to us. And note, since we are not running any sort of asynchronous operations, we don't need to reference and call the done callback. Now we're going to take a look at how to test events. We're going to start off by grabbing a reference to our master element, and then we're going to add an event listener just like we would in our normal code. After that, we're going to apply a callback function within there, and we can do any operation we want, adding any expect statements, such as if there's custom data to our event that we want to test. Once we've wrapped up our tests, in this case there aren't any because there's no additional data that we want to test here, we just need to make a call to our done reference. This is going to let our test know that it's finished its execution. If we don't make this call and it's an asynchronous test, it will time out. Once we've bound our event listener, we just need to make a call to the function that's going to fire our event to execute our code. The other way of dealing with asynchronous tests instead of using the done callback is by returning a promise. The test will automatically resolve once the promise itself has resolved. This allows us to rely on then and catch statements within our promise chain to run our expects at the appropriate time based on the data we have at that point in the asynchronous call. Now that we've finished writing our test, we can go ahead and use the Polymer CLI's command, Polymer test, to run our suite of tests in the browsers that we've got running locally through Selenium. This is going to go ahead and run these tests headless, in my case, against the latest version of Chrome, Chrome 64, as well as Firefox, Firefox 57. The other method we can use for testing our element now that we've written our tests is to go ahead and run it through Polymer serve and then point our browser to the test folder and let it run that index.html file that we created previously. This will go ahead and run all of our tests and provide you the output you see above. You can also run tests individually by navigating to the individual file within that folder. Unfortunately, it doesn't provide you a very good output to view it, but you can open up in console to see what ran, how it ran, and what failed. I hope you guys enjoyed this video on an introduction to unit testing within the Polymer landscape. I'll be releasing another video or multiple videos later on that go into more details on more advanced cases of unit testing, as well as testing elements within the app structure, although they are very similar. If you found this video useful, or if you've got any feedback on the video itself, you can feel free to leave a comment down below. I'll be linking the resources you see here into the description as well. I use them during creation of this video, and I use them all the time when I'm writing unit tests for reference points.